Previously, we have learned how to factor polynomials. We have learned different methods of factoring. For example, GCF, trinomial, grouping, difference of two squares. So x squared minus 9, we can factor it as x minus 3 times x plus 3. You may have been wondering, why do we need to do factoring? X squared minus 9, it seems to be easy enough. Why do we change it to a longer expression? And why do we reverse it to multiplication? So here we're going to look at applications of factoring. Notice multiplication has a very good property, which is if a product of two numbers is 0, then one of them must be 0. So from observing some multiplication facts, if we multiply two non-zero numbers, say 3 times 4, we will end up with a non-zero number. But if we change 4 to 0, say 3 times 0, we're definitely going to get 0. Or we change 3 to 0, keeping the other one, or both of them are zeros, we will get 0. So notice that by observing this, if one of the numbers is 0, then we must end up with 0, because 0 times anything is 0. So we're going to use this property of multiplication. And notice this property only works for multiplication. If it's addition, if I change this to addition, something plus something, when we may have two non-zero numbers, and after we add them, we can get 0. For example, 3 plus negative 3. Neither of them is 0. We still can get a 0. But for multiplication, at least one of the numbers has to be 0. If you have non-zero numbers, if you multiply non-zero numbers, we cannot get a 0. All right, so this is the property we're going to be using. And whenever you have something times something equals 0, we can conclude one of them must be 0. Either the first number is 0 or the second number is 0. So that's when we can set each of the factors. We call, for multiplication, we call each of them a factor. So the first factor, either the first factor is 0 or the second factor is 0. Even if we have 3 of them, this still works. Suppose you have 3 factors, 3 numbers multiplied, we can get 0. Then either the first one is 0, or the second one is 0, or the third one is 0, or maybe all of them are zeros. So for the rest of the questions, we're going to use this property to do the problems. And that's why there are a few things. So first of all, we want to make sure the right-hand side is 0. So that's the first requirement. Secondly, it has to be product on the other side. It has to be multiplication. If it's multiplication, we can set each of the factors equal to 0. If it's plus, we cannot do that. So let's look at these examples here. The first, when we get a equation, notice this is different from what we learned before. The exponent of x could be 2 or even 3 or even higher, 4 or 5. So to solve these equations, we cannot just get x by itself easily, because we won't be able to combine all the like terms. They are not like terms. So previously, when we only have, say, if I change this to 2x minus 5x plus 6, we can combine like terms. These two are like terms to get a single x term. But in this case, x squared and 5x, they are not like terms. We will not be able to combine them to get a single x term and then get x by itself. So the way we learned before, solving linear equations, does not work anymore. So we got to found a new solution. So here we're going to use factoring because of the property we just talked about. So the idea is I can factor this left-hand side, which is a polynomial, a trinomial. Let's do factoring on this. We have learned how to do that. So break down x squared to get x and x. Break down 6. We can get negative 2 times negative 3. And cross multiplies will give us exactly negative 5x. So that tells me the left-hand side can be factored as x minus 2 times x minus 3. the right-hand side, we still keep it equals 0. So in this first step, all I did is to factor the non-zero side, which is usually an algebraic expression, a polynomial. So after I factor the left-hand side, now I can use the property because the right-hand side is 0, the left-hand side is multiplication, and the property right here, if the product of two numbers is 0, then one of them must be 0. So we can set the first factor equal to 0, or the second factor equals 0. And then we can solve each equation from here. And we get two answers, x equals 2 or x equals 3. From this example, we can see the steps of solving an equation with a higher degree other than 1. So it's 2 or 3. The first step, we want to make sure the right-hand side is 0. In this case, we skip the first step because the right-hand side is already 0. So make one side 0. The reason we want to make one side 0 is because when we use the property, we need to make sure the product is 0. So one side has to be 0. After we make one side 0, so for example, the second example, the right-hand, neither side is 0, but we can subtract m from both sides because 48n minus 48n will give us 0. It's sort of like we're moving 48n to the left-hand side as we did it before when we combine like terms. But in this case, we cannot combine them because they are not like terms. We just keep it on the left-hand side. So now one side is 0. Second step, after we make one side 0, we can factor the non-zero side. So the second step right here, step 2, is to factor, this will be step 1, make one side 0. Now step 2, we factor the non-zero side. And notice on the left-hand side, it's they have a greatest common denominator, greatest common factor. GCF is equal to 3n. So we're going to factor out this GCF 3n. And divide each of them by 3n. We get n squared minus 16 equals 0. So that's the step 2. We factor the non-zero side, the other side. Step 3 will be similar to, we'll be using the property here. Since we have product, and we can set each one equal to 0. And notice that n squared minus 16 can be factored further. So we're going to go ahead and do that because it's difference of two squares. n plus 4, n minus 4. So we factor completely. Now the next step is to set each factor equal to 0. In here we have three factors, 3n, n plus 4, and n minus 4. So if we multiply three numbers instead of two numbers, so it could be 3 or more if the product is 0. So as we can see here, look at the step right here. We have exactly the product of 3 numbers equals 0. And then one of them must be equal to 0. Which one is 0? It doesn't matter. So we could have three possibilities. Either the first number, 3n, is 0. So in this case, we divide both sides by 3. We get n equals 0. Or the second number, n plus 4, is 0. So to solve for n, we subtract 4 both sides. We get n equals negative 4. And similarly, the third one could be equal to 0. So we add 4 to both sides. We get n equals 4. So we end up with the three possible solutions. And we can plug each of them into the original equation to verify all three of them are solutions. Okay, so the third step is to step 3. Set each factor equal to 0. And last step will be solve each equation. Put equal to 0. And step 4, solve each equation. Now we're going to follow these steps to finish the other two examples. So in this case, the right side is already 0. So step 1, we're supposed to make one side 0. So these steps, how do you memorize all of them? So if you remember when we solve high degree equation, one possible way is to use this property. If the product of 2 or 3 numbers is 0, then one of them must be 0. So if you remember this property is 0 means you have to have equal 0. That's why we're doing the first step. And the second step, we're doing factoring. Why do we do factoring? Because factoring will change your minus or plus into a product. Because in the property, we need a product. So every step we're doing has a reason there. So the product tells us to factor. And then the conclusion, it tells us one of the numbers must be 0. So that is how we do. That gives us a foundation that why we can do step 3. Why can we set each factor equal to 0? Because that's the conclusion. If the product is 0, then one of them must be 0. So here we're going to check the first step. One side is 0. Second step, make factor the other one. Make the left side a product. And we know this is difference of 2 squares. So we're going to factor it as 5 minus x and times 5 plus x. That's the. So now we have what's required in the property. The product is 0. So we can say, use the conclusion of the property. One of them must be 0. Either 5x minus x is 0 or 5x plus 5 plus x is 0. So that would be our step 3. Set each factor equal to 0. And the final step, we can subtractify and divide by -1. So again, negative x equals -5. And divide both sides by -1. We get x equals 5. In the second case, second equation, we subtract both sides by 5, and we get x equals -5. So there are two answers, either -5 or +5. There are different ways to do this problem here, but when we use factoring, that's how we do it. Now, in the final question, we're gonna again follow these 4 steps. So first step, we make one side 0. We can subtract 4x. And also 35 from both sides. So I combine these 2 steps in one step. So after we subtract 4x from the right-hand side and 35 from the right-hand side, we'll get 0. On the left-hand side, since all of these 3 are not like terms, we just have to keep them there. So first step is finished. The second step is to factor so we can get a product. And notice this is a trinomial. So I'm going to go ahead factor the left-hand side. And you can do this part on your scratch paper if you don't want to show it. Notice that we can factor 4x squared as 2x times 2x. So that would be 4x squared. And we can factor -35 as +35 times -7. And when you do cross multiply, you get -14x plus, and the other diagonal will be 10x, and that's exactly -4x. So we can write down the factoring, the factors 2x plus 5 and times 2x minus 7. So the third step is finished. Second step, sorry, the factoring part. Third step, we can set each factor equal to 0. We got 2 factors here, 2x plus 5 equals 0, or 2x minus 7 equals 0. The final step is to solve each equation we got and to subtractify and divide by 2. So we can just write down the answer, -5/2. And the other one, add 7 divided by 2. So x equals 7/2. And you can also plug the numbers back into the original equation to verify these are both correct answers.